Good morning, good afternoon. This is Monica Paolini with Senza Fili, and today I'm talking to Femi Adeyemi, the Chief Wireless Architect at Fujitsu. And this conversation is part of a report on RAN optimization. And what I'm looking at is how RAN optimization has changed through the years. And the report is being written by Senza Fili in collaboration with RCR Wireless. Femi, well, thanks a lot for being here with us today.
It's a pleasure to be here.
Well, thank you very much. Let's start by introducing and explaining what is that Fujitsu is doing in the area of RAN optimization.
Okay, that's a very good topic. If we look at the history of base stations and RAN in general, we're starting from what we describe to be the distributed RAN, where you have RAN deployed, network managed, network planned in different parts of your locality. These RAN or base stations, they don't communicate with each other. So it's very difficult to optimize that architecture or even be able to plan on the fly as how to expand that network. In the industry today, one of the things that we're doing is we're moving away from the aspect of distributed RAN into what we now call centralized RAN. And in the future, it's something like a cloud RAN or virtualized RAN. This is a big RAN optimization effort. In the sense that the pulling of the baseband away from the distributed RAN that you have at various places and centralizing that in a hub or in a central office has lent you now to a number of things that you can do that would not have been possible in the past. As we go forward, one of the optimization that we want to do is spectral efficiency, where if I have spectrum that I disperse all over the place, with decentralization, I can aggregate this spectrum together, use them efficiently, reduce my power, reduce my cost, reduce how I deploy my network, be able to in an agile manner, revise things on that network without having to wait for somebody to redraw the map, relocate where the base station is. So there are a number of things that we're doing in relation to CRAN that will effectively lead to your RAN network being optimized today and then being prepared for a scaling of the future.
Mm-hmm. So basically, we're moving from a situation where RAN optimization was mostly focused on how you deploy the network, how you build the network, and now the RAN optimization is how you run the network. So it's closer to real time. It's an ongoing effort. It's not once in a while, once when you deploy or to tune it up. It's a continuous effort. Is that right?
That is correct. That is correct. So we're really moving away from spending a lot of time and spending a lot of cycles on just building and trying to build it better. Now we're moving to, yes, I have it built. I have it extended out. How do I efficiently now use this network? This is where the optimization is going to come into play. I can give an example of what we mean by this. Today, one of the big topics that we're addressing is fronthaul, where as I pull the baseband away from that access, the transport between the baseband unit and the remote radio head is now what we call fronthaul. Now, when you begin to densify that access and add more nodes, in this case, remote radio heads, effectively what you're sending to the hub becomes very high data centric, very high data. Now, optimization now says, I need to make sure that the backhaul to support all this dense access that I'm doing is ready. I don't want to if I pre-allocate bandwidth for each of these RAN, I'm just wasting resources. Optimization says, as I'm adding more access, the bandwidth that follows that is agilely being deployed. I don't have to pre-provision the backhaul. I provision the backhaul as the fronthaul is coming in. This backhaul and fronthaul optimization is one of the biggest things that we're seeing in our RAN deployment today.
Mm-hmm. And this is all new because fronthaul, we didn't need fronthaul because all the processing was distributed, and now as it becomes more centralized, we need to deal with fronthaul and manage all of that. So this is a new challenge for mobile operators, right?
Right. It's a challenge for mobile operators. It's actually also a challenge for network deployers,
Mm-hmm.
as well as network equipment providers. Fujitsu is in a unique place because we have a view of both sides. We know how the backhaul works, and we know how the fronthaul as well works. So we're in a very unique place to be able to do this because a lot of our business is the entire RAN solution, not just, you have companies today that are just focusing on fronthaul. You have companies today that are trying to focus on access, small cells. With this, we're in a unique place. We have unique opportunity here to really look at the entire terrain and be able to manage our end-to-end because we have a view of that network from the beginning.
Mm-hmm. And why is it important to have the end-to-end view? Because it sounds in a way obvious, but it has not. It traditionally doesn't happen. As you say, everybody focuses on a special part, but there is a value to bring it all together, right? Well, where does the value come from? Why do you need to know everything? Okay, why can't you just optimize one segment?
Okay, that's a very good question. So let me give you a typical example of how you deploy software onto your RAN. In the past, what we will do is you have an element management system that manages the distributed RAN. When you want to deploy software into this RAN, for each of the RAN, you're actually one by one pushing the new software onto the RAN, okay, when they are distributed. In an environment where you now understand the end-to-end, the RAN that I have in location A may not necessarily need the RAN, may not necessarily need the software in the same location B. When I have an end-to-end view of the resources, the application that I need at specific locations, I can deploy those software from the central location and push them to where they are needed, when they are needed, why I need them. So having that end-to-end view is very, very important because it gives you a global view of the number of users that I'm supporting, the number of sessions that I'm supporting, the kind of application that I need to apply to different locations. So we're moving away from just understanding the access, just understanding the transport, just understanding the aggregation spot, just understanding the deployment of the virtual EPC or IMS, to being able to understand the entire chain, where from the core, if I need to deploy something very fast to the access, I can do that. I don't have to wait for a network technician to come or schedule that 72 hours ahead. We can do that from a central position.
And you can do it driven by whatever the requirements are at the time. So
yes,
you're flexible in terms of changing the network depending on what
dynamically changing the network, dynamically applying new techniques, new optimization to that RAN system, not just a distributed RAN, but the entire RAN system. That is very, very important today.
Yeah, and especially because now with the operators increasingly have access to, well, not only they have the information, but they have better access to the information about how their network behaves, so they have more of a opportunity to understand where things go wrong when they go wrong and take action in a much more
a typical example would be if something is going wrong today in your central location. What we'll typically do is we'll download that information and then go into an office and spend 72 hours to understand, pull the analytics to say, in this location or in this area, no wonder we're having this problem because now many more users are coming onto my network. So now, based on that offline decision, we then go back and optimize the network. What we're talking about now in terms of RAN optimization is an online kind of, you're pulling the analytics, from your SDN controller, and based on those analytics, you can tweak your network immediately because you have policies that you are implemented that will allow you to be able to do this on the fly optimization of your RAN architecture. So this is at the cusp of where we're going. We're laying the foundation for what we're going to be doing as part of 5G in terms of getting analytics from the network, using those analytics to optimize the network as needed, whether it's on the access to add more nodes or in the central location to be able to add more virtual functions as we need them.
And the two, I mean, the two trends, the move from distributed to centralized and the move from physical to virtualized, they're running in parallel. So you're moving towards centralized processing and virtualized so that you free resources. So you gain flexibility on both ends from a hardware point of view, from a location point of view, right?
That's a good point. So if I may use that word, just like you're progressing, that's actually an optimization in itself, right? Where we're optimizing the network from hardware-centric kind of a network today, hardware-focused, hardware-built, purposely built hardware, and pulling all of that back to have a cloud-based or central processing kind of mechanism where the network actually is being automated. In a sense, that's an optimization of the network itself. Then on top of this, now you have the optimization of the operation of the network. So in twofold, you have the optimization of the RAN infrastructure to move away from hardware-centric to server-based, cloud-based implementation, and then operational efficiency with the kind of application that we'll be deploying going forward.
Now, at Fujitsu, as you mentioned, you have an end-to-end experience, so that goes all the way from the edge, from the base station equipment, all the way to the core. How is that helping you in adapting to this new way? Well, adapting and leading the way in this new way, in new ways of optimizing the RAN.
That's a very good question. So I will start from the access, and then we begin to work backwards. On the access, not only are we building the better high efficiency remote radio heads to densify that network, we are very aware of what you need to do in indoor environment as well with the application of small cells or femtocells, so that from the access, when you instead of having separate base station distributed RAN, we're building efficient remote radio heads from low power 1 watt to about 40 watts to support metro, or in some cases where you have bigger organizations, bigger events that are going on, we can have high power remote radio heads to support that. When you begin to move in, then you talk about the transport aspect. Fujitsu is very, very active in the wireline CWDM, DWDM based fronthaul that will support all the traffic that you're generating from that access as it transitions back towards your core. Now, we don't want to limit the operators in terms of how they can deploy the fronthaul, because you have many providers that will be able to only talk to you about CWDM based transport, or only DWDM-based transport, which are wireline-based. In Fujitsu, we support a gamut of transport transport systems, whether it's wireline or wireless. In places where fiber becomes the limitation, we have wireless devices, products that will be able to extend and support your transport. CPRI limitations are not an issue with us. This E-band based wireless fronthaul products that we've built that will operate in the 70-80 gigahertz range is able to meet the CPRI demand of today. So we give the network deployers, the network operators, those options so that you are not restricted where it's only fiber. If I don't have fiber, I cannot do this. But you have the flexibility with the kind of product that we bring into the market. As we move forward, as we move closer and closer into the core, you now come to the aggregation spot where you're talking about centralized base station CBBU. Fujitsu has one of the largest number of sectors that you can support with our BBU. Very powerful and really targeted towards metropolitan area. When you're talking about LA kind of environment where you have dense neighbors and dense access, we go from being able to support 2 sectors all the way to about 96 sectors with the kind of systems that we're building. And then even as you go towards your backhaul, Fujitsu is one of the leading optical provider of transport for backhaul in the industry. So we understand the end-to-end. And when we talk about managing the system or the solution, is because we've been in this business for a very long time. Our network elements have been deployed across it's a global deployment, not just targeted for regional areas. So we understand the different aspects. And so we're able to optimize the RAN and the RAN network based on our experiences in all these areas that I've defined.
So you understand what are the requirements of the very specific segments. Now I wanted to go back to you mentioned CPRI for the fronthaul, and there is also recently there's been a lot of talk about using Ethernet instead of CPRI because of the difficulties with that are sometimes present with CPRI interface. Are you supporting that as well? And what's your view of the balance between the two?
So I'm always very careful when I'm asked this question to ensure that I'm balanced in the answers that we give. People are trying to attack CPRI protocol as the need to move forward into looking at a different fronthaul kind of transport. CPRI is not the problem. CPRI is designed to be able to carry IQ samples from the remote radio head to the BBU. What has happened is that some of the operators, they've implemented CPRI not in the open forum in which it was designed, but to have it as a closed system so that they are able to capture the market on the BBU side and on the RRH side. But the need for looking at other transport in the fronthaul is really determined not by CPRI, but by the fact that as we densify the access, what we are seeing in our simulation and in our work, current work, is that the amount of data that you need to support in the fronthaul will be greater than the 10 gigabits per second max that CPRI supports today. I mean, in our own simulation, we are finding that we will be on the upwards of 40 gig to 100 gig on your fronthaul as we densify the access. That calls for a new transport, which is not going to be CPRI, because CPRI is defined, the max that you can support on CPRI is 10 gig. At 40 gig, then what do we do? So we're looking at existing backhaul transport that we've used in the past. Ethernet has been used in the IT industry. There are some unfortunate things about Ethernet, which we are really now studying to make sure that when we introduce this form of transport, we don't get caught, so that your information from the BBU doesn't end up somewhere else as it goes to the access. So time-sensitive Ethernet is becoming very popular. We are studying that. We're part of that. We are working with our partners now to define proof of concept to ensure that the latencies, the delays, the jitter that CPRI supports, we can actually also support that as part of Ethernet. And by the way, there are also other form of transport that are being evaluated as well. CPRI over OTN, CPRI as part of OFDM. So a number of protocols are being evaluated. It's just that today, what seems to be popular is Ethernet.
Yeah, so I guess that's and again, that this is all developing as operators start deploying CRAN and the centralized architecture, and you have a wide exposure not just to the U.S., to the worldwide customers. What is that you see? What is it you hear from operators? Are they what kind of commitment do they have to CRAN? especially when it comes to combining it with small cells. When they're doing in parallel, moving towards small cells and moving towards CRAN. Is it something that works together? What do you hear from operators?
Oh, that's a good question. What we're finding with the customers that we work with is that they want to do this in stages. As you layer on a centralized kind of architecture, CRAN architecture, you want to layer that onto the distributed architecture that you have today. What you don't want to happen is you take your network apart and then you can no longer make money. So there are two stages of how this is being developed today. One is to overlay CRAN on top of your distributed RAN architecture. And to do that, we are supporting operators today that are starting from the transport and then moving out. So as you build the front haul transport to support CRAN architecture, then in the areas where you have existing RAN locations, you can now densify them with either outdoor remote radio heads or outdoor small cells. Okay, so you can see the connectivity between those two. And then again, then you go back towards your core to now introduce centralized BBU, and you build your RAN in that fashion. Now, what many of our customers are also looking at is when you have new greenfield deployment, you can actually use CRAN architecture to build that out. So in those two kinds of phases or two kinds of scenarios, what we're seeing. Remember, in the Far East, this is already taking shape. It's been deployed, it's been used. The benefits are being harnessed. Savings are being we're finding the savings, the cost savings, the network optimization savings. So what we are seeing in the Far East is what we're now working with our customers to realize in North America.
So are you saying that in countries where you have more of a greenfield deployment for LTE, those are the ones that are more active on the CRAN or moving towards centralized RAN architectures?
No, not necessarily. What I'm saying is that even in North America, where we already have distributed RAN architecture, we are overlaying that with CRAN. Okay, so we're not going in and pulling apart what we currently have and then starting all over. We're overlaying the CRAN architecture with the distributed RAN. One example would be start from transport. All right, and as I introduced the front haul transport, begin to densify now on the access with small cells and small remote radio heads or large remote radio heads. The same operators, when they have new greenfield deployment, right, instead of going back to the distributed RAN architecture, they're now starting out with CRAN. So when you have areas where we need to now have new coverage, for example, in North America, in Southern California, for example, when the opportunity arises to have new coverage, we are going with centralized RAN architecture right off the bat so that we don't have to go and revisit that again. Mm-hmm. But the point, in countries where there is no RAN network today, the best way to do that would be CRAN, because now you can just realize the benefits from the beginning. You don't have to first do something and then rip that apart.
Yeah.
So looking at it from both sides.
Yeah. So it's basically the operators are moving forward, but they have to do so depending on what is the infrastructure that they either have or don't have. So it's a very different way of developing.
That is correct. That is true.
Okay, so now let's look at the future a bit. What is that you're working on next? What are the challenges that we still have to meet, because there's still more ways, more room to optimize the network? What's coming next? What are you working on?
So some of the challenges that we see with many of the operators that we're working with is how do I densify that network? Remember, one of the things that I described earlier is the pre-provisioning that I've already done for my backhaul. It's pre-provisioned, and in so many cases, the access does not even need that. And so we're really working with them to ensure that the backhaul is ready for what the fronthaul densification will bring in. Also, many of our operators, we're finding that the the concept of a virtual RAN is very is something that's very scary, in the sense that you have a general purpose hardware that has worked in the past, that is able to meet all the demands of your network. Now we're talking about, oh, I'm going to give you a server or something in the cloud, and it's on top of this cloud that you now need to run your network. That's a very scary place to be. So we're working with them on reliability. We're working with them on security of this network, so that it's not something that we build and somebody hijacks. So those are the challenges that we face as we move from distributed architecture into centralized architecture. These things we have to work through. Reliability is a very, very big aspect of the network as we virtualize it, right? Resiliency is another one. On your dedicated network, we have tested it, we have soaked it, right? Now on a server, I don't know if that server has the same kind of tolerance as I have on my dedicated hardware. These are important things that we're working through with our operators, as well as scaling of the scaling of the core. Will that virtual EPC scale to meet the access that I'm putting together? This end-to-end intelligibility, reliability are key things that we are working with our customers to ensure.
Mm-hmm. Well, it sounds very interesting and challenging. It's more than just a new box or new equipment. It's really getting the network to work in a different way. So it's all quite exciting. Well, Femi, thank you so much for sharing your thoughts with us today, your insight. It's always a pleasure talking to you.
It's a pleasure to talk to you, Monica. Thank you.
Excellent. And thanks to all of you for listening in. This was a conversation with Femi Adeyemi, Chief Wireless Architect at Fujitsu, and it's part of a report on RAN optimization that I wrote, a sense of feeling in collaboration with RCR Wireless, and it's available for download. Thank you all very much, and have a good day.
Thank you.